In this lesson, I am going to provide a brief overview of the blocks that make up your Step 7 program. I'm going to select the Blocks folder. The Blocks folder right now is in the Small Icons view, so there's not a lot of descriptive information about the various blocks. So I'm going to switch to the Details view. This will list out the different blocks and provide a type for the different blocks that are available. I'm going to select the Help icon and then select the Blocks folder. So inside the Blocks folder, you will have logic blocks, which are code blocks, and data blocks, which are for storing user data. In the Help, I will select logic blocks. The first type of block is going to be an organization block. Organization blocks form the interface between the PLC operating system and your user program. So the PLC operating system will call an organization block first, and then from the organization block, your user code would be called. I will select the function block link. Function blocks are subroutines that store local data. So if you need to store data from one block call to the next, a function block allows you to store the data in the form of an instance data block. I will select function. Functions are subroutines that do not have that dedicated area in the form of an instance data block. Both function blocks and functions allow you to pass parameters into these blocks. I will select data blocks. Data blocks are for storing user program data. There are shared data blocks, which are global, and there are instance data blocks, which are associated with a specific function block for storing local data for those blocks. You will see the System Data folder. The System Data folder is for storing your system data blocks, which is your hardware configuration. There are also UDTs, which are user-defined data types, so you can create your own data types, and then declare elements of your UDT. There are also variable address tables, or VAT tables, for monitoring and modifying data during program execution. I will select my Help icon again and select my OB1 block. The OB1 block is an organization block. This is a program cycle block. So this is your main program. There are a variety of different organization blocks in the system. Another type of organization block, as an example, would be a cyclic interrupt. Cyclic interrupts interrupt your program at fixed intervals. So every 500 milliseconds or every 100 milliseconds, you would like some code to execute. OB86, as an example, would be a rack failure. So if you have a remote I/O fault, this block would be called. Select OB100. This is a startup OB. So in an S7-300, if you use the OB100, it's a warm restart block. So when your CPU transitions from stop to run, the code that is in the block OB100 will be executed one time. I'm going to close the Help. If you want to insert a new block into your program, you can right-click on the Blocks folder and select Insert New Object, and then you can pick which type of block that you would like to insert or object that you would like to insert into your program. So I will just show you an example of a few different blocks. So I'm going to open up my OB1 block, which is the main program block. I could scroll down in this block to show you the different examples, but I'm going to just select the Networks tab. And this is a quick way to jump to various networks within a block. So in this main program block on Network 9, I have an example of a function block. So I will double click on Network 9, and that will take me to Network 9, and I can see the function block example, which is a subroutine that stores local data in the form of an instance data block. So at the top of the block is the definition for the instance data block. So DB2 is where data would be stored when the block is done executing, and so that data would be available the next time around when this block is executed. I am going to open up the function block, FB1, which is my machine control block. So I'll select call block and open. Code blocks have an interface area. The interface area defines the parameters that go in and go out, what's stored locally in the instance data block, and what's stored temporarily during execution. The in area is for declaring your input parameters that go into the block. The out area is for declaring parameters that are passed out of the block. In-out are read-write parameters. Stat parameters are for storing data inside of the instance data block. In-out, and stat elements will all be stored inside of your instance data block. The temp area is for elements that are only going to be known during the execution of the block. So in the in area, I declared an element called machine cycle, and you can see that's being used down here as a local element inside of this block. I'm going to close this function block, open up my main program block, select my Networks tab, and I will open up Network 7, which is an FC call. So FC2 is a function. A function does not have an instance data block that is associated with it. So I will right-click on FC2, select called block, and open. Just like in FB, the FC has an interface area where you can define your in elements, your out elements, in-out, temporary, and a return value. FCs do not have the stat area for storing data from one call to the next. I will expand out the in area, and then you can see there's a start element and a stop element, and those are being used locally inside of this block. So those are block local parameters. The block local parameters are preceded with a pound sign. I will close the FC, and I will look at DB1. DB1 is a shared data block or a global data block. So the data for this block is known throughout the program. I will open up DB1, and you can see the individual elements that are created. So data blocks allow you to store data of a variety of different data types. In this case, I just have Boolean values inside of the data block. I will close out this data block. DB2, this is the instance data block. So I will open up DB2, just select yes. So the instance data block is based off the definition of the function block. So in the instance data block, you will see all of the in elements, out elements, in-out elements, and stat elements. I will close the instance data block. In this lesson, I went through a brief overview of the different blocks that are used within a Step 7 program.